1. This is Unit 2. We're going to do Unit 2 and 3 today, hopefully. Topic 1, waves, EMS, and spectral lines. What does EMS stand for? Electromagnetic spectrum. Okay. What does it go from? What's the most energetic part of the EMS? Gamma. And it goes all the way down to radio waves. Okay. We talked about the relationship between wavelength, frequency, and the light we see. Do you remember that? Okay, first of all, wavelength looks like that. Do you remember that? Yeah. Okay, and we know that, what about wavelength?
1 over.
We know that if the waves are long, what do we know about the frequency? Low frequency. If the waves are, what's the opposite of long? Short wavelength. So we know that the frequency is high. Draw better waves than your teacher. Okay. We also know that different wavelengths equal different types of light or color of light. And you know within those colors there's also different shades. So there's reds, blues, etc., right? Okay, we know that there are 2 types of spectra. Do you remember what they were? There was line and continuous. Oh, yes. Okay, line spectra. Continuous was like a rainbow. They all blended together. And a line spectra was what? Literal lines. Okay, and when we looked at literal line spectra, what were we really talking about? I can't draw this thing anymore. Which one are like fingerprints for atoms? Line or continuous? Line or like fingerprints. Okay. So, what else did we remember? I think that's it. Oh, no, there was more. I'm going to talk. I don't have room. I ran out of room. We talk about an electron configuration. What happens when light hits an electron? So here's an electron minding its own life. There's N1, N2, N3, and N4. Do you remember what N equals? Principal quantum numbers. Also means what? Like energy levels, right? Okay. So we have an electron sitting here minding its own business. Do you remember when it was at its lowest energy possible, what we called it? We call it at ground state. And then we shoot some light at it. Okay. And then what happens to that electron? Gets excited. And what happens when it gets excited? It moves up to some other energy level and it's super excited. It's excited, but is it happy to be there? It can't be there forever, right? So it has to eventually go back down to the mundane part of absorbs light. Okay, so the electron absorbs the light, then it's super excited, so it's at a higher energy level, but eventually it's sad and it wants to go back home. So it goes back home by doing what? Yeah. Which turns into light, which is the light your eyeball will see. Yes. Okay, and then your light sees it, and the electron goes back to ground state, where it's comfortable and happy. Do we remember all of those things? Now you do. Okay, so remember ground, excited, how it moves in between those two. Excited? Yes. I'm trying to write better with this pen. I don't know why it doesn't write well anymore. Probably should calibrate it. All right, can I go on? this down because I can. Okay, now are we in electron configuration? Okay, what do you remember about electron configuration? Oh, do you remember that there was that important paper? Bring that into the exam. Do you have it still for Unit 2? Okay, it has all the shells. So 1s2, 2s2, 2p6, all of that for electron configuration, ... Right, there's different levels, right? Okay, so for an example, if I have 2p5, what does the 2 stand for? Yep, my energy level. Okay, what does the p stand for? My suborbital. And what does the number 5 stand for? Number of what? Of electrons in the suborbital, right? Okay. That doesn't give you a good one. What if I have an electron configuration like this and I want to find out okay.
There's an example below.
Yeah, I know, but it's not the example. It's not giving me what I want though. Okay, so here's a random example, 1s2, 2s2, all the way up to 4p2. Okay, where are the valence electrons in here? Added an extra line. Okay, we go for the highest number in front, or the highest energy level. Remember that? And if there are two of the same, what do we do to the electrons? We add them. So 2 plus 2 is still 4. So there's 4 valence electrons in this element. What element is this? Remember I said go 10, 20, 32. Which element is 32? I don't know. Maybe I'll have a table around somewhere. There's 20 of you, and not one of you has a periodic table. I got up and I walked by.
It's right here.
45-year-old butt over.
There's more over there?
GE. No, I'll make more. Okay, the 10s took them all. Okay. So the example here, same idea. What is it? Where's valence electrons? Valence electrons are 5. There's no other 5, so it has 2 valence electrons. What element is this? Remember I said 10, 20, 30, 38, 42. What are the initials? MO? MO? Okay. Write and draw the electron configuration of tin. Where is tin? Tin is 50. Hint, hint. Yeah. How do we draw tin? Draw the electron. Writing is different than drawing. One is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. What's after 4p6? 5s2? Sure. Or 3d. No, we did finish 3d. I don't know. Who has the thing in front of them? Oh, wait, I have it in front of me. 4s2. Did I do 3d10? I did 4p6. Oh, yeah, then I went 5s2. That was right. 5s2, 4d10, and then 5p2, I believe this should be. Is that right? Okay, that's writing. Drawing, also on that cheat sheet. Do you remember when we did the energy? And then we did 1s. And then what did we do in the sunny and the pink rooms? Yeah, 1p. No. I did it wrong. 1s, what comes after 1s? 2s, thank you. What comes after 2s? 2p. After that, 3s, and then 3p. Oh, rough here. Okay, then 4s, then 3d10 has 5 spots, and then we go to 4p. 1, 2, 3. I can't draw 3d10. I ran out of room. 4p. Yep. And then we go to 5s. And then we go to 4d10, 4d, and then we go to 5p. Okay, do you remember how to put electrons in here? What do they look like? Arrows. So we fill Sunny first with 2 arrows going opposite spin. Okay, and then we fill them all the way up. So to draw it, you probably have to write it out first. Does that make sense? Okay. And 2 at the top. What do I do with those 2? Do I group them together? No. Very good. And they have to be the same spin. So the arrow has to be pointing the same way. How do you draw an excited state? If I give you sodium, 1s2, 2s2, 2p6, good, 3s1, and you're going to do 2 excited electrons. What would you do? You just move 2 around to a higher energy level, right? So 1s2, 2s1, 2p5, 3s2, what's after s? 3p1, something like that, right? So as long as you move 2 and it makes sense where you move them, that's how you get the marks on that one. Okay, moving on. Electronegativity, all of that good stuff. What is electronegativity? It's the ability of an atom to attract electrons. So it's atoms' ability to attract electrons, not attack, electrons and steal them from everybody else. What is the most electronegative element on our periodic table? It's F. Okay, if you can remember it's F, then you can remember which way the arrows go. So we go towards F. So we would increase electroneg going across a row. And if we go from top to bottom, electroneg will also increase as we go up. Okay? The other ones that we had to remember or know are atomic radii and ionic radii. I think, yep. So atomic radii, do elements get bigger or smaller as I move the way the orange arrow is pointing? Decreases. Good. Why? Because they're almost at what number? 8. And they're happy at 8. Okay, so what atomic radii and ionic radii both follow that trend. Okay, getting closer. Now, as we go down the periodic table, what does the radius do? Gets bigger or smaller as we move down? Bigger. So the atomic radius does what? Radii increase. Look at that. Atomic radii. It's moving while I'm writing. Radii increases. Okay, good. Okay. And why does it do all of that? There were 2 things we talked about. Number 1 was the octet rule, and number 2 is the shielding effect. Octet rule is specifically what? 8 is our magic number. Shielding effect was like a blanket. Do you remember that one?
Yeah.
What is it? Adding an extra shell adds an extra layer of shield. So more shells, so that's energy levels, right? Means more shielding. So it's hard to get through. So if you think of a blanket, you put the blankets on, multiple blankets to get more heat. Okay, moving on in 3, 2, 1. We just talked about what electronegativity is. Do you have your periodic table of electroneg? You'll need that for the exam. Okay, so make sure you have that and bring that. Your cheat sheet has the chart. Ugh. In fact, right. Cheat sheet has chart. Okay. So when we're calculating this, we go O and H. We're looking for the bond type between the two. Okay. So O, so we're going to go, what are these line things called? Absolute. So O is 3.0. We're going to take it away from hydrogen, which is 2.2. These are just completely made up numbers to relate two things together. Okay, we take the difference between that, and that is 1.3. We go to the chart on our cheat sheet and look up what 1.3 means. What does 1.3 mean? Very polar covalent. Do not write the words, write the short form.
What is the top, like,
Periodic table of electronegativity. So you need to bring that to the exam. Okay? Ca and I. You're going to be like a whole stuff. Okay. What's Ca? Is 2.21. We're going to take the difference between that and 104, which is from iodine, and we're going to get a value of 1.17. We'll go to the magic chart on that magic sheet, and it'll tell us as well that it's very polar covalent. Okay, so there'll be a couple of those on the exam. And that's that unit. Okay, any questions, comments, or concerns about that unit? Did we do that in record time?